Dear students, today we have the last module about layered approach for network softwares, how they communicate between each another. So we started with a real-time example in first module, followed by a real example how a data is transported from one software to another software over the network. So today we will more focusing on the basically concept of network layer and then link layer, and we will also learn that what are ports and how the data on the port are listened and transmitted. So we were discussing that the network layer, when they receive the packets, so now we are on the other end where the data is being received. So it uses forwarding table to send the packet to the next router. So it also see that whether the final destination have been arrived or not. If it's already the final destination, then this layer will give the packet to the transport layer. So otherwise, after giving the next address, this layer hands over the packet to the link layer and ask link layer to process the packet to its destination by looking the forwarding table. So the link layer then goes deep inside and see if the network is, for example, Ethernet, then it should adopt or it must adopt CSMA CD, which we have learned in one of the other module about collision detection. And then if it's a Wi-Fi, then it will use collision avoidance technique, which we also learned in one of another module. So when the packet is received to link layer, on the other side, it's sent to network layer, again whether the final destination has been arrived or not. So at each step, packet's final destination is compared with the forwarding table details, and network layer gives back the packet to link layer, and these two layers are basically the only two layers involved in intermediate steps of the airlines, which we discussed in the first module of this series. So forming the core of the router. So in the routers, only these two layers are available. And then routers can forward the packets in millisecond. So this is also very important to know. So for example, if there are 50 routers in between when your packet or data is sent from one place to another place, and if each router is taking seconds, so then it means that your data will be transferred in 50 seconds or in a minute. However, each router takes milliseconds to transport or to route the packet to the next router or next destination. So network layer recognizes when the packet reaches to its final destination. Packet is then handed over to the transport layer, which assembles the original message, and then after looking at what are the sequence numbers of each packets, and then reassembles and then give back to the application layer. Then there is another concept that about the port numbers, that when the data is given from transport layer to the application layer, so within the application layer, which unit will be listening to that particular data. So for example, if there is an application layer that is listening or that is basically performing tasks to listen about the HTTP request, FTP request, and etc., SMTP request. So how it will recognize that on which unit should be activated to receive the data. So determining which unit within the application layer should receive an incoming message is an important task, and this is handled by assigning unique port numbers. So you assign that this packets or this activity should be listened to port number, for example 80, port number 90, port number 20, etc. However, there are some accepted port numbers for widely used applications, like browsers always contact HTTP servers to get access of their data at port number 80. Similarly, simple mail transfer protocols, when they are finding way to get mails from the servers, the client always communicate with the application layer on the server at port number 25. So, to summarize today's module, we have learned more about network layer and link layer, and we have seen that how the ports are defined and why the ports are important in such communication. So, today we are finishing the modules on network hierarchical or layered approach to internet softwares for communication over the network.